Hi class, we're going to take a look at a couple of conversions that involve temperature. And for temperature, these are the most common temperature conversions. The only difference here is what you're going to see with the Kelvin. As a notation, we don't put the degree symbol, and you will see that the degree symbol is actually placed on Fahrenheit and Celsius. Okay, so let's take a look at the first problem. They want us to take a look at 86 degrees Celsius, Fahrenheit, and we're going to be expressing this as Celsius. So let me use the proper formula. In this situation, it's going to be this formula, and I'm just going to rewrite it as C is equal to 5/9 times the values of F minus the values of 32. And technically F is equal to the values of 86 degrees. I'll put in the degree after the evaluation. So in this case, let me just rewrite it. And we're talking about the values of C is equal to 5/9 times 86 minus 32. And this is going to be equivalent to 5/9 times 54. And this is going to be reducing. So we can reduce these two. And this will be technically 5 times 9 times 6 will give us a 54. So let me just rewrite it at 9 times 6. And then we can cancel the 9s. And then we're going to be left with the values of 5 times 6 or 30. And let me rewrite it as the values of C is equal to 30, and then we'll put it with the proper symbol. So let me express it as 86 degrees Fahrenheit is equivalent to 30 degrees Celsius. In the final answer, I am expressing it with the proper units, in this case, the degrees Celsius. Let's take a look at the next one. Problem 2, they want us to go from degrees Celsius to Fahrenheit. And let me just rewrite the formula. We're looking at this formula. So this one's going to be the values of F is equal to 9/5 times C plus the values of 32. And then technically C is equal to 37 into the formula. And that's going to be there. Let me rewrite it. This one, we're going to end up with a decimal. So F is equal to 9/5 times the values of 37 plus 32. Let me actually punch this one into the calculator so that you guys see it. So let me write it as 9 divided by 5 times the values of 37 and then plus the 32. And that's going to give us a value of 98.6. So 98.6 as the final answer. So in this case, F is equal to 98.6. And let me rewrite it with the units. Let me double check 98.6. Okay, and then rewriting it with the units. In this case, 37 degrees Celsius is equivalent to 98.6 degrees Fahrenheit. That's actually it for these two. Let's move to example 3. Some of the problems, they could be messy, that you could be given a value with decimals or something really messy. So the software for some of these is expecting that you're using a calculator. Let's take a look at example 3. And Please read example 3, but they're talking about two basic measurements and they want the maximum temperature in degrees Fahrenheit. So your maximum temperature is going to be 32 degrees Celsius. So let me rewrite it as maximum is equal to 32 degrees Celsius. And we're going to express this measurement in Fahrenheit. So let me just show the formula again. This will be the 9/5 times C plus 32. So Fahrenheit, so F is equal to 9/5 times C plus the values of 32. And then C, we're going to be punching in the values of 32 for this one. So 32 will be evaluated here, and we're looking at F is equal to 9/5 times the values of 32 plus 32. And this one's going to give us, let me punch it in into the calculator. Oh, we could have just done, let me just do the whole thing. So 9/5 times 32, we are going to end up with a decimal plus another 32. I'm getting 89.6. This is 89.6. Okay, and let me rewrite it as a sentence. In this case, the maximum temperature is 32 degrees Celsius, which is equal to 89.6 degrees Fahrenheit. And that would be the maximum temperature to use the weed killer. Let's take a look at example 4. Now, here is a minor discrepancy with the formulas that we're using. So all of these formulas are just estimators. And that means that there's other formulas that could be used. The one that's given by the author here is a regular K plus the values of 273. And in terms of degrees Kelvin, they're using 273 unless they want you to use a different value. So in this case, for example 4, you're using the 273 times the 0.15. And they want us to, convert 28 degrees Celsius to Kelvin. So we're just going to say that in this formula, C is equal to 28. And then the values of K is equal to, this will be 28 plus 273.15. So that's going to be 301. So K is equal to, I'm getting 301.15. And let me just punch it in. So 28 plus 273.15. Oh shoot, it's 302. So 28, oh, no, never mind. It's supposed to be 28. So 28 plus 273.15. Okay, 301. Okay, so the measurement was actually correct. And let me just express it that 28 degrees Celsius is equivalent to, in this case, 301.15 degrees Kelvin. Now, in terms of the notation, we don't use the symbol of degree for Kelvin. We would have left it as 301.15. And let me check it again. I typed it in wrong. I typed in 29 and it's supposed to be 28. So 301.15. And the measurement, we don't put the degree symbol here. This is what I was referring originally, that in the units conversion factors, you do put the degrees on Fahrenheit, on Celsius, but not on Kelvin. So the proper notation is on Kelvin, you just put a K, and it's understood that we're talking about, well, degrees Kelvin, but without the symbol of degrees. So for problem 4, that would be our final answer, that 28 degrees Celsius is equivalent to 301.15 degrees Kelvin without the symbol of degrees. That's actually it for these problems.